Day 7,
Hello and
Car
welcome
Audio
back to
School.
day 7. We were just talking about DC current and AC current. We finished the definition of DC current, so we're going to start on AC current. And just to reiterate, this is Car Audio School. The school is going to help you do your own install, become a technician, or own your own shop. This is for entertainment and educational purposes only. This is my online resume, and my goal is to help you not have to go into a shop. You can do this yourself. Of course, if you can't, you can bring it to me, but let's continue with alternating current. So alternating current is a characteristic by a flow of electric charge that periodically reverses direction. This polarity, or its magnetic field, alternates between position positive and negative. So it has two directions it can flow, not just one direction like DC. Alternating current is alternating current. Polarity. So the polarity of an alternating current, or AC, continuously changes, oscillating between positive and negative at a specific rate. This periodic change is visually represented in the source by the waveform that goes above and below the zero line. So that's that imaginary line I was talking about, going above and below, which is a cycle, but we'll keep going. This periodic change is visually represented in the source by a waveform that goes above and below the zero line. Music and audio signals generally considered AC are generally considered AC due to their rapid change in polarity, which causes a speaker to move. So when you see a subwoofer push in and push out, that is utilizing alternating current. This is how we get sound out of speakers. Frequency. So AC has a frequency component, which refers to how often the current changes direction. Frequency is measured in cycles per second or hertz. For instance, the electrical supply in a household wall socket in the United States typically delivers at 60 hertz. In some regions, and what's funny about that is this also translates over to film. We may get into that later, but there's a lot of similarities. In some regions, it might also be around 50 hertz. The source mentioned 110 volts AC and 120 hertz at 60 volts AC as household supply in the US. Hopefully that made sense. Indicating potential variations or different standards to be discussed. So when you're over in the UK, they have actually different power supplies. Once I redo all of this, I'll have visual representations and probably some animations to show you how all these things work. But yeah, I'm gonna, this is a dry run. I'm gonna clean this up and make it look good for another video. I'll have a side note thoughts to talk about those things. All right, so amplitude, potential. AC also has an amplitude component, which is its potential measured as voltage. When measuring AC voltage, especially in audio systems, it is essential to have a constant signal source like a test tone or a pink noise for reliable measurement. So most of the time when you want to tune a vehicle, you would get a real-time analyzer, which kind of acts like a oscilloscope. I have one available, but I'll actually show you how that works, because there's no way I can do it as it is right now. Where do I leave off? AC voltage can be measured by using a DMM digital multimeter by tuning the meter to the appropriate AC voltage setting, and then note that the source incorrectly states to turn it to ohms for AC voltage. No, there's actually a AC dial on your multimeter that you need to be on to be able to test for AC, just like DC. And I'll show you that. I may get my multimeter, not now, but I'll get my multimeter. Oscilloscopes are also used to visualize and measure AC signals, and they often have a AC/DC coupling setting. AC coupling removes any DC component from the signal, which can be helpful in certain measurements. Now, that is kind of complicated. I'll get to that later, probably when I bring a multimeter up and show you what dial you're supposed to be on. Sources and applications. Alternating current is primarily electrical supply found in household wall sockets. While a typical alternator in a vehicle generates AC power, this AC then is converted into DC or direct current through a process called rectification using diodes. Diodes would also show up on wiring diagrams just to show you where they are. This DC power is used to charge the battery and run the vehicle's electrical system. Sometimes, if the diodes in the rectifier are failing, some AC can leak through, causing a phenomenon called or known as AC ripple, which can lead to noisy audio systems. Now, for that, I've always found that the Chevy Suburban or like Tahoe, no matter what, every time you put an audio system in that vehicle, you will always hear a hum or dirty noise or like a static sound, like from a TV, and you hear that static or with the revving of the engine, that noise will climb with the tachometer or the RPM. It'll climb with that, so it'll get louder when you step on the gas. I've always found that it is always the alternator. I haven't been able to prove it because nobody will let me take their alternator out and prove it, but if you were to upgrade your vehicle, it will go away. Some people try to use ground loop isolators, which will somewhat remove that AC ripple. No, that particular case, it's either the power wire ran with all the other electrical wires inside the system, or it is absolutely the alternator every single time. This AC ripple can be measured using a DMM, digital multimeter, or a oscilloscope. Music and audio signals are fundamentally AC, with their charging polarity driving the movement of the speaker to produce sound. I have some more notes here. They're not really important. I'll give them to you anyway. In essential, the key difference lies in the direction of the current flow. DC flows in one direction, one constant direction, while AC periodically reverses its direction. Both forms of current are essential for powering a vast array of devices we use daily. Understanding this fundamental difference is crucial in various applications, from household electricity to automotive electronics and audio systems. For example, understanding AC and DC is necessary to fulfill the grasp of how crossovers work in audio systems. Similarly, when working with high-end current electronics, especially in hybrid and electric vehicles, it is important to be mindful of both AC and DC systems and avoid direct interference of low voltage accessories with high voltage DC systems. This is really talking about making creating a magnetic field, because anytime you have and I don't want to say this wrong, but anytime you have electricity flowing through a conduit, be it electrical wiring or whatnot, it creates a magnetic field that can leak into, we'll say, RCA cables that are going into your amp, that are coming out of your amp, going into your speakers and emitting out of those speakers. So garbage in, garbage out. That's pretty much it. We're back at 12 minutes again. So I will leave notes in the bottom. Donate, donate, donate. Tip your technicians because they work really hard, and this is a lot of information. I know this information, but I'm not good on camera yet, so I'm getting better at that. Beyond that, we are trying to get 3 different tools: Direct Tech, Mitchell 1, and ALLDATA, so we can go over what goes where. You can call in and ask questions. That's going to be set up soon. I'm going to set up the desktop so I can show you examples, and yeah, we will be back tomorrow with another one. Thank you.